Today we dive deep, quite literally, into one of the strangest and most alarming environmental mysteries of recent times. Between 2013 and 2016, a massive patch of unusually warm water appeared in the North Pacific Ocean. Scientists called it the Blob. This wasn't science fiction. It was real, spanning hundreds of miles and disrupting marine life, weather, and ecosystems on an incredible scale. What was the Blob? How did it form? And what were the consequences of this mysterious marine heat wave? Let's uncover the story. It all began around late 2013, when researchers at the University of Washington noticed something strange off the coast of Alaska. Satellite data revealed an enormous area of ocean water that was much warmer than normal. In some places, up to 3 degrees Celsius, about 5 degrees Fahrenheit. Hotter. At first, scientists thought it might be a short-term anomaly. But as weeks turned into months, this warm patch didn't fade. It grew. By early 2014, the Blob had stretched across a vast area of the North Pacific, reaching from Alaska down to Baja California, Mexico. They called it the Blob because, like the classic horror movie creature, it just kept spreading, swallowing more and more of the ocean in a shapeless, unstoppable form. The question on everyone's mind was, why did this happen? The answer lay in the atmosphere above the Pacific. A persistent high-pressure ridge, nicknamed the ridiculously resilient ridge, hovered over the ocean for months. This ridge acted like a lid, preventing storms and winds from stirring the ocean. Normally, winds help mix warm surface water with the cold, nutrient-rich water below. But without that mixing, the upper layer of the ocean just kept getting warmer. This calm, stagnant ocean created the perfect environment for a heat trap. Scientists also believe that climate change may have amplified the event, making it longer and more intense than it might have been in the past. By mid-2015, the Blob was one of the largest and longest-lasting marine heat waves ever recorded. The Blob persisted for nearly 3 years, from late 2013 until early 2016. During its peak in 2015, sea surface temperatures in the affected regions were 2 to 3 degrees Celsius above average, covering an area of over 1.6 million square kilometers, roughly the size of India. This warm water anomaly completely disrupted the normal rhythm of the North Pacific. Even when El Niño developed in 2015, scientists noticed that the Blob didn't simply disappear. It merged with those patterns, magnifying their effects. But what happens when the ocean gets too warm? The results were devastating. The first victims were at the very bottom of the food chain. The Blob reduced the amount of nutrient-rich cold water that usually rises from the deep. That meant fewer phytoplankton, the tiny plants that feed almost all marine life. With less food available, small fish like anchovies and sardines began to decline. And when small fish disappear, so do the creatures that rely on them. Along the Pacific coast, hundreds of sea lions, seabirds, and our fish are either starved or washed up dead. One of the most shocking moments came when tens of thousands of common murres, a seabird species, died in one of the largest mass die-offs ever recorded. The Blob also triggered outbreaks of toxic algae, contaminating shellfish and forcing the closure of fisheries across California, Oregon, and Washington. Salmon runs plummeted, marine mammals struggled to find food, and entire ecosystems were thrown off balance. The Blob wasn't just a warm patch of water, it was a slow-moving disaster. But the chaos didn't stop at sea. The Blob's heat affected the atmosphere too. Coastal regions of the U.S. Pacific Northwest and Western Canada experienced unusually warm, dry winters during the years the Blob persisted. Snowfall dropped dramatically, river levels fell, and drought conditions worsened. Meteorologists even linked the Blob to strange weather patterns across North America, including intensified droughts in California and unusual heat in Alaska. It was a powerful reminder that the ocean and the atmosphere are deeply connected. When one changes, the other responds. By early 2016, shifting weather patterns and strong storms finally broke up the Blob. The ocean slowly returned to its normal temperature, but its impact didn't vanish. Scientists later discovered that the ripple effects of this event continued for years, with many marine populations still recovering long after the heat wave ended. The blob taught us a crucial lesson. The ocean is not immune to climate change. Marine heat waves like this one are becoming more frequent and intense, threatening marine ecosystems, fisheries, and coastal communities worldwide. It also served as a warning. What happens in the ocean doesn't stay in the ocean. From marine die-offs to weather shifts, the effects can reach every part of our planet. So what was the blob? It was a glimpse into our planet's future, a world where rising temperatures don't just change the weather, but reshape entire ecosystems.